Thank you very much, actually, to Abel, Daniel, and Momita for bringing me to this CBC group. So from last year, I think first time in Berlin and later on in Hong Kong, I had the opportunity to share some of my research related to the blockchain in construction. And since then, this is from previous talks, basically we developed blockchain-based systems for off-site construction, ranging from manufacturing to cross-border logistics supply chain, and also on-site installation, the three key scenarios of off-site construction. Since last year, we had some new developments. So last year, we developed this into a portfolio, and then some of the private developers, they are designing and manufacturing some complex facade. So they wonder whether it is possible to use our blockchain system to for the inspection of the quantity. And then another government, actually Hong Kong Housing Authority, it's a huge portfolio with public housing in Hong Kong. They are interested in using our system for cross-border logistic and supply chain. And recently, they start to adopt the blockchain systems in their new public housing projects. We actually have some new consultancy works coming in now. So really happy to see the industry is adopting the blockchain systems. But perhaps more important things over the years, from our first blockchain construction project, we start to collect some very good data. So very good data stored in blockchain and also stored in some database, traditional database. So for example, for this case, this is a Hong Kong University student dormitory project using off-site construction technology. Here in Hong Kong, we call the MIC, Modular Integrated Construction. So the project used the system to monitor all the quantity inspection process in the Pearl River Delta factory, and the data actually capture all these things from the project. So I can give some brief description of the data. So for each module you have around more than 40 steps, and then you can take photos, videos to record the inspection process with timestamp, with the operators. By having the data, you are able to form a Gantt chart, as you can see from the right-hand side figure there. So in this case, we have 960 something modules. Each module you can see from the detailed process of the like a 3D structure, like a concreting, like MEP. So this is a really highly structured big data. And we show this data to industry people. They say that the integrity of the data is really impressive. So yeah, this is inspection data. We have project monitoring, scheduling, quality assurance, simulation, optimization, and management and decision making. And now we have another project also using the system. And this project is even in bigger size, more complex, and it is able to capture another set of big data. So from which you are able to probe into the project management or production management process. So for example, a few cases, this is another project, and now I think they have collected more than 300,000 photos for the 1,241 modules. So a very obvious application of this blockchain system is they don't need any paper-based inspection anymore. So it's purely based on we call the e-inspection based on the blockchain system. And whenever the government departments, like buildings department, are still requiring some paper-based documents, and this can be very time-consuming because you need to fill a form and then attach a few photos, like normally 4 photos. There is a disparate case in Hong Kong. Actually, each big rebar, the client needs an inspection form. So it's really time-consuming to do this in paper-based inspection form and inspection in a traditional way. So in this case, the project team is purely based on the e-inspection. Whenever the government department requires any paper form of inspection, so they can easily pull out the photos and the materials and automatically generate the form. Okay, so and then pass to the government departments. So this is one of the very easy application. So based on the big data, we are also able to re-examine the setup of a factory for this offsite manufacturing. We call the MIC, as I just mentioned earlier. So for example, it is possible to simulate and optimize the facility layout for a modular construction manufacturing, given that we have the detailed data, okay, for this 3D framework. So for example, it takes 5 steps, and at the time consumed in each step is A, B, C. And also, for example, for concreting, we have some other production data. I can say this is perhaps the best modular construction production data in the front you can ever find. So based on the data, it is possible to simulate different facility layout design. We also know practice make perfect. So we want to see whether there's a kind of learning effects in this modular MIC manufacturing. So if we go back to the Gantt chart, this is real life Gantt chart. So you can see the production time for a module. Okay, from the very beginning, it's long, and then after some learning effects, after they practice, they undergone the learning curve, the production time now is becoming better and better, shorter and shorter as well. So we are able to identify the learning effects from the data during the MIC manufacturing. On top of that, it's actually possible, for example, to shorten the learning curve for some teams. And also, based on the big data, it's possible to plan the production phases, okay, from one point to another. So it is, you can see, we published some paper in ASE journal, and it's purely based on the big data we have, and we aim to develop some like lean MIC production planning. We have a lot of other examples in terms of production management. For example, we also want to match the off-site production with the on-site. So for this kind of a high-rise MIC projects in Hong Kong, we still have some central core that is conducted using traditional CAS Institute on-site. So how to match the off-site and the on-site using the big data is a big area that we can use to manage the project management. Another area we are trying to develop at this moment is Now, thinking we have some very good data, we are trying to develop a blockchain-enabled smart payment. Perhaps you have heard about smart payment enabled by blockchain smart contract quite a lot, but I search around, perhaps there's no such real life application at this moment. But it seems we are now coming to the first real life smart payment case in Hong Kong in this MIC project. So we all know some of the pain point problems. We like to use this term in this part of the world. So a lot of problems in payment, particularly for offsite. So a classic, dispute is the the production manager or contract manager on the two sides. One's from the client side, another is from the front line or from the production side. They always have some dispute on the progress or on the amount of the project or the production they have done. So they want to reimburse for that part. It's a classic debate or dispute between the two parties. Now, thinking you have all the detailed real life production data from the front line, from the factory, it is possible to resolve the dispute and to enable such smart payment that will bring in a lot of other benefits. For example, the few claim cases, or if the payment is paid always on time without a dispute, the cost of importing the financial financial cost is lower, so that can reduce the tender price as well, because the construction cost in this city is now higher and higher. So we are trying to develop such a system. I think it will be get funded soon. So the point here is from the big data, as shown in the Gantt chart or as captured in the blockchain, we try to match it back to the bill of quantity or to the contract sum. So to have some like a different progress of the work stages. For example, by the inspection now, this 3D like a framework, steel framework has complete 80%, for example. So I should pay the 80% from the amount that has been stipulated in BQ, bill of quantity. So we have developed an architecture of the system. The key here is to, as I said, is to calculate the amount of work that has been really done and that has been mutually agreed by the front line and also the client side or its representative through the blockchain, because we have a mutual agreement between, it's a consensus mechanism of blockchain. So we published a paper on this by focusing on this payment freezing and disbursement cycle. We certainly know that Martin Fisher and his PhD student developed something very good from in Stanford University. Actually, a few days ago, I met with Professor Martin Fisher in Hong Kong. I mentioned this case. So for his team, I think they are much more forward-looking and to broadcast the payment information across the whole supply chain, so putting suppliers and subcontractors on the same page as a way to enable smart payments and also to have some like a tokenization of the fund for this blockchain system. So we must say our system is not going that forward, but it's more practical. It's focused on using blockchain to have the consensus of the construction or production progress as the basis for the smart payment, for the payment on time. So we may get Martin's team and also his PhD graduate on board in doing this. We all certainly, we know also our friend Marcus is also developing some system for the construction smart payment. He has even developed some ways of invoicing, issuing the invoice, okay, to the client for payment. I think I have mentioned to him that we also will involve him on board. I also noticed later on there will be a presentation on a system review of blockchain and a smart contract for payment. I would be very interested in listening that. Okay, so these two aspects are more kind of related to the big data we have collected in the blockchain system. And also having a PhD student doing something, it's called a machine learning on blockchain, okay? I think this is more forward-looking, and it's not. I think it's not yet a very practical application, but I'm happy to share it with you. So the student Ziming is working on this, and we notice for blockchain or for machine learning, we have some classic dilemma among accuracy and security and efficiency. Okay, so if you want to achieve some higher accuracy, maybe the efficiency will be compromised. If you want to achieve higher security, maybe the efficiency or accuracy will be compromised as well. So for some machine learning applications, in real life machine learning applications, it is possible you have to hit and balance among the three indicators. So the student thinks to use blockchain, for example. And traditionally, we put data on the blockchain. Okay, it's a redundant mechanism. We put a part of data here and there, okay, in a distributed way. So his idea is whether it is possible, I also put the machine learning algorithm in a distributed way, also on a blockchain. So that's his main idea. So he has done some research already by putting both the data input and also the machine learning computing on blockchain, and then allocate the blockchain system and try to make this happen. So he has found a way that last time to increase the security, but the compromise of accuracy and efficiency is also acceptable. So we put this paper in the system for peer review. Next steps. So we probably will focus on another area. So to focus on the efficiency, for example, whether we put the data in the edge, okay, in a blockchain, in a distributed way, it is possible to just do the machine learning computing in the edge, in a distributed way, whether that can also increase the efficiency. And well, some other accuracy perhaps will be compromised. We try to find out the relationship among the three dilemma on different blockchain configuration, on different machine learning configuration. I think we still have some problem in finding real life applications. Although we said, oh, for example, for inspection, it is possible for people to tamper the data. Now we put the blockchain, the data in blockchain, so it's not easy to tamper the data. Whether it is able to tamper the machine learning algorithm themselves, yes, maybe that is possible, but it is difficult to find the real life cases. Actually, a reflection, as I mentioned, the projects we have conducted in the industry people is rather successful, and they would like to pay as a consultancy for the research. But it seems to us, industry people either don't have the expertise to understand the blockchain, or they're not really interested. And once they heard, okay, my material, my information is secured in blockchain system, that's fine for them. So I think that's also a reflection then whether this machine learning on blockchain whether really go to that security level, that accurate level. So we still need to find some real life cases for that, but it's a rather good scientific exploration at this moment. So, and also interesting, last time in earlier in October, I went to Marrakesh to attend the CIB W78 meeting. I think my colleague Gang Li, the son of Daniel, you probably know him, from Korea. He asked a very sharp question. Perhaps that's also a question for us. Is it Wilson? Is it really necessary? We need a blockchain system, okay? Because we traditionally doing some database with in some encryption. It is fulfill the security purpose already. But I have some reflection, and I can answer that question. But I want to also put this question to all of us. Thank you.